Energy. Let's start with the definition of energy, or what it is. It is the ability to cause change within a system, and it is measured in joules. Now, a system is anything that you want it to be. Let's say you raise your hand in the air to get your teacher's attention. Well, there was a change in the position of your arm. So there was a change in that system. In order to raise that arm, your body had to use energy. So if there is a change in a system, energy was used to make that change. So the definition is the ability to cause change within a system. And the system can be really anything that you want it to be. And energy is measured in joules. The unit for energy is joules. And anytime you do work, you are causing a change in a system, and you are using energy to do that. There are 7 different forms of energy that you will need to be able to identify and recognize. To help you remember these different forms, we use a mnemonic called Mr. Sense. The M in Mr. Sense stands for mechanical energy, or the energy of motion. This dog is running and he's moving, so you can see that that is an example of mechanical energy. The R stands for radiant energy, and that's the energy in the form of light, like from a light bulb, or the light we see from the sun, or the light that is given off by a fire. It can be a glow stick, a match, anything that gives off light. That light is radiant energy. The C is chemical energy, and this is energy stored in chemical bonds. When atoms bond together, there's energy holding those bonds tight, and if those bonds break, then that energy is released. When you digest, when you eat and digest food like an apple, the process of digestion is breaking down those chemical bonds, and so the energy is being released. A battery is also an example of chemical energy, and we're going to watch a quick video clip that describes what exactly a battery is and how it is an example of chemical energy. So if you never really knew what a battery was, you're about to find out just how they work.
Maui, the most advanced user interface. I need an advanced user interface.
Skip that. Parts. Right here in the anode is where your chemical reactions are taking place, and the result of those chemical reactions are these electrons. So chemical energy. The electrons want to get to the cathode, but the electrolyte insulates it, so the electrons can't go through the electrolyte to the cathode. So instead, they have to travel on some kind of a conductor, like a wire. So these electrons begin to move through the wire. Along that wire, they might encounter something like a light bulb as they make their way over to the cathode. Once the anode is no longer able to produce new electrons, the chemical energy of the battery has run out, and your battery must be replaced. All right. Moving on in Mr. Sense, we have the E, which is electrical energy. Electrical energy is electricity. Basically anything that uses electricity, either electricity produced by the moving of the electrons in the battery or an electrical outlet of some sort. Anytime we have moving electrons, these moving electrons will produce electricity, which is a form of energy, electrical energy. The N is nuclear energy, and nuclear energy comes from atoms. There are two different processes. Fission is when one atom splits into two. The atomic nucleus here, the middle part, splits into two. So it would be like one helium atom splitting into two hydrogen atoms. So that process of splitting a nucleus in half is fission, and all of the energy stored within this nucleus is released when that process occurs. The second nuclear process is called fusion, which is the opposite of fission. Fusion occurs when two atoms run into each other really fast and at really high temperatures, and their nucleus, both of their nuclei, fuse or join together into one. That would be like two helium atoms running into each other, or two hydrogen atoms, running into each other to produce helium. Fusion is the process that occurs on the sun. This fusion gives off much more energy than fission does, and so those are the examples of nuclear energy. The T is thermal, and thermal is heat. So anything that is hot has thermal energy. Like us, we have thermal energy, and when our body is feeling sick or we have an infection, then our thermal energy increases. We get a fever, and that fever is meant to try and heal us from the infection. Then the S is sound. Sound is vibrations. Any vibrations produce sound. Speakers create vibrations in the air, which move to our eardrums, and our brain then interprets those vibrations as sound. When you hit a drum or bang on a xylophone and the surface begins to vibrate, it will produce sound energy. So you might ask yourself, are there different forms of energy, or different types of energy, Are there different types of energy? Well, you might say, yeah, you just told me there are 7 different types of energy. But not really. Energy is energy. There are no different types of energy. Now, energy can be seen in many different forms, like we just talked about, but energy is energy. There are different ways to store energy, and the 2 different types of energy storage are kinetic energy storage and potential energy storage. Kinetic energy storage is the energy that's stored in the motion of an object, and potential energy is energy stored in the position of an object. What I would like you to do is create a Venn diagram, and I want you to place these statements down here into the section you think they belong. Is that statement a statement representing kinetic energy or potential energy? Or is it a statement that represents both? You would put it here in the section where the 2 circles overlap. So what I want you to do is pause the video and complete this activity. Now that you've had a few minutes to complete the activity, let's check your answers, and please feel free to make any corrections as you need. Kinetic energy is energy stored in an object's motion, so motion, storage because of motion. Kinetic energy, the amount of kinetic energy an object has depends upon the mass of the object and its velocity. The bigger it is, the more kinetic energy it's going to have. The faster its velocity, the more kinetic energy it's going to have. The mathematical formula for calculating kinetic energy is 1/2 the mass times the velocity squared. So you square the velocity, you multiply that by the mass, and then you multiply that by 1/2. These are some examples of kinetic energy storage. Electrical current, which as we've seen is a result of moving electrons, so we've got movement. Sound energy, again, movement of those vibrations. Radiant energy, which is the movement of light photons. And thermal energy, because heat can definitely move, like from a fire to your hands or from a hot chocolate cup to your hands. So thermal energy is heat can move. So that's an example of kinetic energy. Potential energy is energy stored in an object's position. The amount of potential energy an object has depends on its mass, the gravity, and the height. So the larger the mass, the more potential energy. The larger the gravity, the more potential energy. And the higher an object is above the ground, the more potential energy it's going to have. The formula for calculating gravitational potential energy, you take those three factors, the mass times the gravity times the height. Some examples of potential energy are magnetic energy, that's energy stored within a magnet or a magnetic field. Chemical energy, that energy being stored within chemical bonds. So those bonds are just, they're related based on their position. All right, so we have chemical energy is potential energy, and elastic energy based on the position of an elastic object like a rubber band, and nuclear energy, energy that's being stored in a atomic nucleus. Both of these energies are types of energy storage, so that statement would go here in the middle. Make sure you have corrected anything that maybe you put in the wrong spot. Make sure you get it into the right spot. So let's quickly recap what is energy, and feel free to start singing if you find the beat being a little catchy. I won't judge. Don't judge my singing.
The rolling boulder crashing down the mountain, that's kinetic energy.
Kinetic.
The boulder sitting high upon the mountain, that's potential energy.
Potential.
Energy in motion is kinetic. Energy that's waiting is potential. But whether it's kinetic or potential, both of them are energy.
Olay!
You stretch a rubber band and then release it. That's kinetic energy.
Kinetic.
You stretch a rubber band and then you hold it. That's potential energy.
Potential.
Energy in motion is kinetic. Energy that's waiting is potential. But whether it's kinetic or potential, both of them are energy.
Olay!
The heat that comes when gasoline is burning, that's kinetic energy.
Kinetic.
The energy that gasoline is stored up, that's potential energy.
Potential.
Energy in motion is kinetic. Energy that's waiting is potential. But whether it's kinetic or potential, both of them are energy.
Olay! All right, hope you enjoyed that. And that is all I have for you today. I'm out.